Hi, everybody, and thank you for tuning in for this webinar on Core Web Vitals in 2023 and beyond. We're going to talk a little bit about why, though you may think Core Web Vitals rolled out a year ago, it's done and dusted now, why actually it's something that we do need to keep on thinking about, looking ahead to, and it's definitely a living, breathing thing. Google want to keep improving it, want to make it a bigger factor, in my opinion. So we're going to go in a little bit of detail why that is and what we can expect as Core Web Vitals continues to develop. A little bit about myself. I am Dave Cousin. I'm the head of organic at OBAN International. We're a digital marketing agency, and we specialize in helping clients move into new markets or do a better job in markets they're already in by really tailoring for the needs of the market. But let's get on to Core Web Vitals. So there may be some people watching who don't know so much about Core Web Vitals. So I'm going to do a little bit of a recap for everybody. And I think there are some misconceptions around Core Web Vitals. So you may find that I tell you something you don't know, or I may just confirm what you already knew, and then you can be really pleased that you already had everything spot on. So the 3 Core Web Vitals, these are KPIs that were added by Google to the existing page experience part of their algorithm. So page experience metrics that already existed were mobile friendliness, use of HTTPS, and no intrusive interstitials. And there was another one to do with avoiding content that was basically deceptive practices, I think is how they covered it. So that one's now still in the algorithm, but a little bit separate. But this part of Google's algorithm is all about user experience, and getting the best user experience. And so these Core Web Vitals are basically a way of measuring which sites are doing the best job of creating a site or pages that, as far as users are concerned, are just great to use and easy to use. So one of the Core Web Vitals is largest contentful paint. That's to do with loading and speed. Then there's first input delay, which is to do with interactivity of the page, how quickly it reacts. And then cumulative layout shift is to do with visual stability, so making sure that elements on the screen aren't jumping around when you're trying to interact with them. So these are all things that on a poor site are frustrating to real-world users. And so Google basically came up with a way to measure that and reward sites that are doing a good job. So this started rolling out on mobile back in August 2021. It was pretty much fully rolled out by then. And then desktop, Google said they were rolling it out in February 2022. There's been little word on whether they actually did that or not, and to what extent they've done that. But let's for now work on the assumption that it is active on mobile and desktop. At the same time, they made these other page experience KPIs more important, showing just how Google see themselves as kind of gatekeepers for quality of websites, and kind of want to throw their weight around a little bit in terms of making sure that website owners are creating great sites. And if you have pages which do pass all metrics, at some point in the future, Google have said that they may actually highlight those. So that's all 6 of those page experience metrics. Now, that's something that there's been some questions about whether that's actually ever going to roll out. And so that may not happen now, but Google did in the past say that that's going to happen. So we'll wait and see on that one. But potentially that'll be another advantage. So that'll potentially boost your click-through rate if you pass all of these. Despite what some people may think, there is potential for Core Web Vitals to have a major impact on rankings for all sites, basically. But most importantly, if you're in a very competitive area, and for now at least, and I'll talk a little bit more about why it's only for now, but for now it is a factor which is often a deciding factor where everything else is equal. What good will look like, so a good score for these core web vitals, is something that is going to continue to change. We're going to talk about that a little bit more. And crucially, there are other core web vital KPIs which may be added in future. As I said, there's 3 core web vitals, but there are other web vitals which we're going to look at, which are currently not core web vitals and not part of the algorithm. So that's important to remember. So why should you care? Either if you are somebody who hasn't really thought about core web vitals before, or somebody who feels that core web vitals is done and dusted, you don't really want to think about it again. It was a lot of hard work, made a lot of developers very unhappy. Well, hopefully we want to revisit this again. So it is, I believe, going to be more important in the future. And that's based partly on some things that Google have said, and just the general direction that Google are going in terms of trying to improve the quality of user experience on the internet. It already can be a defining factor, or maybe a refining factor in terms of making the final decision on who comes top and who just misses out when all other things are equal in terms of the optimization of the page. And while not everybody would have seen this, I think it's worth pointing out that sometimes if you haven't seen an impact, even though you've done lots of work on core web vitals, there's a very good chance it's because all your competitors were also putting a lot of work into core web vitals. Every client that I've worked with over the last few years has been putting a lot of work in. And so you'll never know exactly how much you would have suffered if you hadn't actually put the effort into core web vitals and fixing those. I think also there are some studies that have shown that there is an impact for sites that have failed to keep up. There's a good one from Systrix, where sites getting poor ratings for those core web vitals are on average 3.7 percentage points lower in terms of visibility than those that are getting a good score. So there is a measurable impact already. Yeah, those core web vitals are going to keep changing. So if you are doing really well for the 3 core web vitals now, it could be that this time next year, there'll be different web vitals which are using the algorithm, but maybe those you're not doing so well for right now. But you can check, and we will get on to. And then the other reason why you should care, even if it wasn't part of the algorithm at all, and it's just a way of measuring, because it's going to improve your user engagement, it's going to improve for your conversion KPIs and other related KPIs, and just make your users happier and like you more. So that's worth doing. And lastly, there's no excuses for getting poor scores for these core web vitals. What good looks like isn't actually that tough at the moment. And unless you've got a very badly designed website and very badly designed platform, it isn't that you need to start again with a new website. Most of the time you can find fixes on your current site. All the time you can go back to your devs and say, look, this should never have been like this in the first place, sort it out. So there is no excuse for bad web design, and bad web design is really the only reason why you're going to do badly for these core web vital scores. So firstly, before I get into a little bit more detail on what each core web vital actually looks like, and then talk about some future web vitals and what we expect to see over the next year or so, I want to just say a few things around data and monitoring, which is one area where there is a lot of misconceptions and a lot of confusion. So I'm going to talk about the difference between field data and lab data. So just to be clear, when Google measure core web vitals, they are using Chrome user experience data, which is data that comes from real world users. And for that, they're using field data, which is 28 days data. So that's a rolling 28 days, which means if you make a change now, which drastically improves one of your core web vitals or all of them, then to actually see the full impact of that in the data will take 28 days. So Chrome user experience data comes from real world users using Chrome who've opted in and said they're happy to share data. But you will also see lab data. And that lab data is basically a robot checking a page and trying to replicate what a user would see. So it's only the field data that's used in the algorithm, so that's really important to remember. And sometimes the field data and the lab data will be very similar, but there's a lot of reasons why it won't always be. With the field data, you will only actually have that field data used by Google if there is enough data for it to be trustworthy data. So it has to be a certain amount of people who've opted in and visited that page. So some of your less visited pages may not have enough data. However, Google do now group similar pages together. So if you've got an e-commerce site and you've got loads of product detail pages for all your different products, and each of them individually don't get enough traffic to actually register to have enough field data, but they're all based on the same template. Google can tell they're the same template. They'll group all of those together, which means if you've got one fairly popular product which has some massive image that takes forever to download, or one of them's got a video on which takes forever for the applet to load, that can impact your score for the largest contentful paint, for example. So worth bearing that in mind. So lab data is useful where you don't have enough data for field data to predict how your core web vital scores are going to look like. So that's really useful when you have a new site, new templates, and you want to check how they're going to perform before you roll them out. And that data is available both through page speed insights and through the Chrome user experience Crux API as well. Now, one important thing to mention about the sources of those two bits of data there are that first input delay is not available through page speed insights for lab data. It's only available through the Chrome user experience API. And even then, as we'll talk about a little bit later on in a bit more detail, it can be a little bit inaccurate, so worth bearing in mind. So each of these metrics, each of these three core web vitals, the actual scores and what good, average, and poor actually look like are based on some values. But LCP and FID, that is based on milliseconds. The cumulative layout shift, it is based on a score, usually between 0 and 1, sometimes over 1. And when we get to talking about cumulative layout shift and I've explained what it is, I will explain how that score works in a little bit more detail. But the important thing to remember for now is, yeah, there's different levels for what good, average, and poor look like. And these are the current values that are used. Google do also provide scores separately, which particularly with the cumulative layout shift can be confusing. Those are a little bit less reliable, I found. So I would recommend focusing on the values, and the values won't change over time. What good looks like, what the scores look like may do. So let's talk a little bit more about largest contentful paint. So this is probably the core web vital people are most aware of, and maybe the one that was easiest for us to approach because it's very similar to page speed, which is something that as SEOs have been thinking about and looking at for a long time. But it isn't exactly the same as page speed. It is one way of trying to measure page speed, thinking about a user's perception of page speed and trying to reflect how a user might perceive page speed. And that is to identify how long it takes basically for the largest element within the first fold of the page to actually show. So We have an example here. This is one provided by Google when they first said they were going to roll out Core Web Vitals to make it easy for us to understand what that actually means. So first, Contentful Paint, which is a Web Vital, but not a Core Web Vital, therefore not in the algorithm, at least for now, is basically how long it takes for the first contentful element to actually start showing on a page. So that's over on the left there. Now, if that page stopped loading at that point, that would also be the largest Contentful Paint. And you can only understand what the largest Contentful Paint score is once a page is fully loaded. So those three images in the middle, at that point, the largest element is this block of text, which is the headline of this page. And if it's stopped at any point when that's still the largest, then the timing for largest Contentful Paint would be based on when that first showed in that second frame there. But once the page is fully loaded, this image shows up. And that image is the largest element within the first fold of the page there. Now, there is another image further down the page, and for all we know, that could be a bigger image, but the part within the first fold is smaller. So that's why that one doesn't count. So we've got this one element that's showing, and that's what the timing is going to be based on. Now, there's lots of ways around largest Contentful Paint to try and optimize it without actually really improving user experience. And this is one of the reasons why Core Web Vitals may keep on changing, because LCP and some of the other metrics are not perfect. And a lot of people have complained about the fact that you can manipulate LCP by, for example, making sure you've got a big image that shows up nice and quickly, even if the rest of the page is then really slow. So you get a really good large Contentful Paint score, but actually it's still frustrating for users. Few things, to bear in mind there. I definitely wouldn't recommend optimizing for just that one element. If the rest of your page is fast and you just got one element that isn't fast, then obviously there are things you can do to improve. So if you had this example here, you could make sure that image isn't too large, is the right size for the device, and so on. One other thing I'll just quickly mention is, do bear in mind that the element which is the largest Contentful Paint element will vary depending on the screen size and depending on the device. So it could be that when this same web page shows up on a desktop device, that the layout gets changed, maybe the headline's bigger, or maybe another element's bigger, or maybe the picture that's further down starts to show up, or even just on a larger mobile device, it could be that that picture down the bottom does show up, and so actually you'd have a slightly quicker large Contentful Paint time because that shows up sooner. So let's have a quick look at some common causes of what causes poor largest Contentful Paint. I would say, though, that I've come across over 50 different reasons why largest Contentful Paint is poor. Some of those page speed insights are quite good at picking up on. Sometimes they misdiagnose a little bit. Some of them involve a little bit more digging. Some of them are also quite easy to fix, and some of them maybe not so much. Some cases you can actually find, okay, there's 20 things wrong, but 50% of the time it's being lost are down to 2 things that need to be fixed. It's always worth considering how much time is being lost to different elements so you can prioritize. In this example here, we have a website which we look at the mobile site here. For this, I turned on throttling to see what a real-world user using a smaller device on a slower connection would actually see. And because this website is showing this header image here, which is very high definition, and you're not going to be able to see all that definition on a mobile phone, so there's no advantage to it, but it's still got to download this massive image, even if it's on a slow mobile connection. So that's slowing things down. Easy fix there. Make sure that you're sending an image in a format that's as efficient as possible for size, and also smaller sizes for smaller devices, and potentially even smaller sizes for people who are on slower connections as well. Really important this if you're going into a market where people do tend to kind of be on mobile and tend to be on slower connections. If you're going into a market where actually most people use a 3G connection, then it's going to be totally different to if you've previously been on a market where it's a 5G connection. So these kind of things worth bearing in mind. Otherwise, you may find that even though in your tests you've seen a great score, when you actually roll it out into another market, you're suddenly getting really poor scores there. And you can turn on throttling within Google Developer Tools to see what the load time would look like on a slower connection. A couple of other really common issues here. So firstly, on the left here, we've got a site which has got some CSS and JavaScript files with a high percentage of the file not being actually used on the page. It could be that it's being used elsewhere on the site. It could be that there's CSS and JavaScript there. It's only used on one page. They're having to be downloaded for every single page. So those could be split out into separate files or moved in line. And it could even be that actually these pieces of JavaScript are being run and nothing's actually being outputted onto the site from these as well. So it can actually slow down when these are actually executed, as well as just the size of the file that needs to be downloaded. So yeah, if I was working on this website, I definitely would want to talk to the devs and say, can you have a look at here and see what's actually necessary? And then another one on the right, loads of web font files here. As we're going to talk about in a minute, also this has an impact on cumulative layout shift. So a couple of wins here by cutting these down, making sure the files are as small as possible, considering whether actually they're all needed. Could some of them be have a fallback font used instead? So some good opportunities there. So moving on to cumulative layout shift. So this one is something that I think everyone's experienced at some point when you're loading up a web page and you go to click on something, the thing you want to click on is loaded, it's right there in front of you, and as you go towards it, no, it's moved and you end up clicking on an ad or on a link somewhere else, and suddenly you're on the wrong page. Hugely frustrating. And Google are aware that people get frustrated by this, and so they want to make a better web. And so they are forcing website owners to avoid that. And usually there's 2 or 3 main things that cause these issues, and usually they're fairly easy to fix. So firstly, how is this actually calculated? So it's to do with the total movement as a percentage of the element size. So if you've got a large element that moves a little bit, this will have a bit of an impact on your score, can be a bit bad. If you've got a small element that moves a lot, and that's also can be quite bad. If you've got a large element that's moving a lot, suddenly you get a really bad score. And if you've got loads of different elements and they're all moving around, then that can be really, really bad for your scores. Now, generally, scores are between 0 and 1, but it is possible to get a score of over 1 where you have multiple things moving multiple times. So one thing to mention, don't worry about stuff that's caused by interaction. So if somebody's interacting with a carousel and it's moving, yes, that's supposed to happen, that's fine. And as with LCP, stuff outside the viewport, that initial kind of window doesn't matter. And neither do things that are loading later on once people interact with the page. So let's have a look at an example then. I'm going to go through some of the common fixes for this. So in this example here, we have a page that as it loads, let's go pause it there. We have this block of text show up initially in orange here, and then we've got some space up here where something's going to load. We've also got this text up here, over to the left here, and then I'm going to roll this on. And suddenly everything's moved. We've lost that text completely. Oh, let's automatically skip forward. Let me try and pause at the right place again. There. No. And every time I pause it, it's moving forward, which is annoying. Tell you what, I'll just put it on and see if it will just go on a loop. So we've got the fonts are changing there. We've got images that are coming in, things moving down. So this all comes down to three main issues. One is elements that are loading and hasn't been defined within the page, within the document object model, where things are going to sit. So as far as the browser knows that something's going to load here, but doesn't know how big it's going to be. And so if it's waiting for an image to download or something else to be generated by a script, it has to wait until that's done and then move things around to fit it in. There's no reason why we can't tell the browser beforehand, this element is going to be this big, therefore keep this space back. So that's one solution. The other one is to do with web fonts. So web fonts are specific fonts you want for your website, match your branding and so on. But while those files are downloading, those font files, the site will use a fallback font. Now, if that fallback font has been chosen to have a very similar footprint, then it might be a very slight kind of movement that you see when the web font loads. If you've got a completely different fallback font, as in this example here, then everything potentially is going to move around. Stuff that's on one line will move to 2 lines. And you've got a few images moving in here as well. And again, those are ones that could have been defined, the size for those beforehand. So that's cumulative layout shift. And then going to move on to first input delay. So the last of the 3 current core web vitals. And then we're going to talk about some of the flaws of these ones and why these may not be the permanent core web vitals. Now, first input delay is probably the one that people have the most problems with. It's maybe the most difficult to understand in some ways. It's very difficult to actually measure and to predict because it really depends on how people interact with the page. And it's also one that there are other potential web vitals that could replace these. So first input delay is to do with interactivity, as mentioned earlier. So it's actually to do with how quickly a web page will respond when you try and do something. And that something could be clicking on a link to another page. It could be interacting with something like a web form. It doesn't include scrolling or zooming. And if users come onto a page and they don't interact with it in any way, they just click the back button, let's say, or close the window, then nothing gets recorded. And so nothing gets passed back to Google from opted-in Chrome users in that case. Now, when a robot comes and tries to replicate this, it's going to try and guess what a user might do. But the reality is users will most likely interact in a particular way. And the only way to really kind of understand that is to test real users or wait until you have enough field data. It's worth saying at this point as well how this actually works in the background very briefly. So basically what's being measured is when somebody interacts with a page, there will be a delay if the main thread that the browser's using is already processing something else. So in this diagram here, we have a user clicking here. The main thread is running this task here. It could be a script, something like that. And therefore, the browser can't respond to that input until that script has finished loading. So the user may be aware of a delay and might get frustrated, might click refresh, might click back. So that's a very good reason why Google have decided to include this core web vital. So what does that look like on a real site? So I've got an example here. So the top here, we have a picture from Developer Tools from the performance section that's measuring all the things that are happening when a web page is loading. Now, in this particular example here, you've got the first Contentful paint, the largest Contentful paint over on the left. You've got the DOM content load quite way over on the left. And then you see this script all the way over on the right, so quite a lot later that's loading. So what that means is that the site is already, as far as the user's concerned, loaded up. So they may be trying to interact with it, and then there's this long task later on. So if somebody's clicking and trying to interact at that point, then they're not actually going to get anything happening for, let's see, 327 milliseconds, which may not seem like a lot, but Google have decided that that is too long. So what it actually is on this particular website, Pet Plan, they have a chat function here. Now, they've probably purposely delayed that from loading, maybe lazy loaded that, so that it doesn't impact largest Contentful paint, probably. But the impact of that has been that while that is loading up, people are clicking on the menu, clicking on Get Your Price, and having that delay. So this is why they're getting a poor first input delay score there. So moving on to INP. So this isn't a core web vital yet. INP is interaction to next paint, and it is a new web vital, the newest of the web vitals, that was introduced recently. And yeah, all of the noises being made by Web Vitals and by Google are that this could well become a core Web Vital in future. And it's very likely that it would replace or maybe complement first input delay, which a lot of people feel doesn't work especially well. It's a little bit more complicated in some ways, but maybe it's actually better judgment of a user's perception of how interactive a website is. So what it's really checking is when you click on a page and try and interact with it, how long is it until something changes on the page and something actually shows up? The reason why this is different to first input delay, I suppose, is because if with first input delay, it could be that the browser's reacting, but nothing's actually showing because multiple scripts are running in the background. And because first input delay actually is measuring the time until the main thread is idle, that doesn't necessarily match up with what a user's actually seeing on the page. Whereas this is to do with the next paint or the next frame being presented to a user. And so everything that goes into that and much more matches how a user perceives that. So it's experimental for now. Google are taking feedback on INP, what's good about it, what's bad about it, what just isn't quite working properly. So they're not quite ready to roll it out yet, if that is what they're going to do. My prediction is they will do at some point, but I think they will announce it a little way ahead of time, as they tend to do. The way it's calculated is based on either on the worst interaction speed, where there's been more than 50 interactions. So, sorry, if there's been less than 50 interactions. And so if most of your users are getting a perfectly good experience, but there's one particular thing that they could do on the page, which would result in a bad interaction speed, then you would potentially still get a poor score, even if most people are actually getting a good experience. So worth bearing in mind. If there's more than 50 interactions, it's based on the 98th percentile. So still, quite kind of small numbers need to be getting a bad experience for you to get a poor score. So worth bearing that in mind. So let's have a look at a couple of examples of this. We've got a good example and a bad example, which are actually both from the same website. And this also illustrates how to fix this problem quite easily. So in this first example, we have interacting with this page, selecting something, and the next frame is actually there where it shows it loading. Now, if there was just a delay and there's just a blank screen or nothing happened at all, then that would have got a bad score. But because they've designed it in such a way that there is this confirmation graphic to show that something is happening and it is responding, you just need to be patient, that actually gets a really good score. They didn't do that with this one on the right here. And even though the delay is fairly imperceptible, partly because you can't see exactly when the click's happening, there is a 616 millisecond delay there before anything actually is changing on the screen where those clicks are happening. And that's getting a poor score. Yeah, certainly one of the fixes is to think about having those confirmation graphics showing while something's processing. Then also just making sure that the interactive elements on your site are done in such a way that they maybe can't be used until, or don't show up until they're actually ready to be interacted with. So if they're still loading in the background, that can be another problem as well. A few other potential fixes there. I'm not going to go into all of them at this point. Unfortunately, yeah, this session is not on how to fix Core Web Vitals, something I'm very happy to talk about if anyone wants to get in touch, but not the focus for today. So interaction to next paint, something that you probably should be starting to get ready for. So let's look more to the future of Web Vitals. So what good actually looks like is very likely to change. I think most people feel that Google were planning to roll out the page experience update, including the importance of Core Web Vitals, and make it pretty major. What actually happened was when they started rolling it out and started testing it, I think they found that because some pretty major authoritative websites hadn't got up to speed quickly enough, they would have dropped out of at least the kind of top few positions, if not the first page, if Google had rolled it out in the way that they wanted to. So they had to make it a more minor algorithm update. That doesn't mean, though, they don't want to roll it out as a bigger part of the algorithm. So it's partly waiting for those sites to catch up. And one way Google could also make it a bigger factor is to change what good looks like for now, make good a lower score than those ones we saw on the slide earlier, especially for LCP, which is the one that most sites, most pages actually fail on. So slightly tweak what good looks like in order to make sure that the sites that they want to keep showing at the top do, but then maybe some other sites get rewarded and the really bad ones get impacted as well. But then long term, I think Google are actually going to make what good looks like even tougher. I think they'll do that partly because as high-speed fiber broadband becomes a more standard thing and 5G connections become a more standard thing, then people's idea of what good looks like and people's expectations will change. We think about, how quickly we expect a web page to load on our mobile phones now. We'd have been amazed by that kind of 5-10 years ago. So things will change and Google will have to change what good looks like. So you need to think about, even if you've just got a good score now, like, could you make it even better? And Google definitely, a lot of things they're saying, they see themselves as this benchmark, see themselves as having responsibility for setting web standards and making sure that people are creating great quality websites. So they will keep on trying to improve that and find new ways to measure page experience. So it could be that it's not just swapping Core Web Vitals, but adding new ones and adding other elements to this part of the algorithm. So here's what I think could be added or could be swapped. Largest contentful paint. A lot of flaws with that one. So it could be swapped for something like Speed Index. Speed Index is a Web Vital that is currently available. You can measure this. You can find out that if Google were to decide to move to this, whether you would still be getting good scores or not. Speed Index is a little bit more complicated because it's a more detailed algorithm that takes lots of different elements of how a page loads into account to come up with a score. So it takes a little bit more computing power, I think, and maybe that's one of the reasons they're not using it at the moment. But I think that there's definitely one of the options for the future, or it could be a brand new Web Vital that doesn't exist at the moment, that does a better job of really understanding how fast a web page is. First input delay, as mentioned, that could be swapped for interaction to next paint. So definitely worth keeping an eye on that. I'd say just go in to PageSpeed Insights now and start to understand, are you passing for INP now? Particularly if you are passing for FID and you're not passing for INP, then the sooner you can start working out why and looking at fixing that, the better your chances of getting that fixed before Google potentially roll that out. But my opinion is that they will do at some point, sooner or later. Time to interactive and total blocking time. Now, there's an appendix with this, so definitely worth you downloading these slides and having a look at that appendix, where I go into a little bit more detail on what exactly those are. But very briefly, time to interactive is the time it takes for a page to fully load, become fully interactive. Total blocking time is all the different scripts that run and the total time they take when added together for a web page. They could be added as additional core web vitals, or they could be used to swap for something like FID as well. So the action really is optimize now. Even if these web vitals never become core web vitals, never become part of the algorithm, if you're getting good scores for these, then you're also delivering a good user experience. So they do have value, whatever happens. They will improve your conversion rates, they'll improve your interaction rates. So really worth spending some time looking at these sooner rather than later. As I mentioned, there's an appendix. I'm not going to go through this now, but a quick definitions of all of the core web vitals and those other web vitals that already exist. And then a summary of each of those core web vitals, including some of the common fixes and what tools you can use to actually check for these and check what's going wrong. And then the same thing for those other web vitals as well. So hopefully a good starting point for actually going and looking at what's going on in your site at the moment. So that's everything, but got some time to go through any questions. So I've got a couple of things coming up on the chat here. Yeah, how to access lab data. So the lab data, along with the field data, is available in PageSpeed Insights, and you can go in there and you can check for individual pages. There's also an API for PageSpeed Insights. As I mentioned, lab data isn't available there for first input delay. So if you want the lab data for first input delay, but as mentioned, consider that it is a robot trying to replicate what a real human might do, then that is best to get through the Chrome User Experience API. If you're not particularly adept at using APIs and connecting to those, then I believe there are some tools available for Google Sheets that will allow you to connect to that directly. You can put in a list of URLs and it will pull the data for those. It takes a little while to run and bring that all back, but you can use that. Then let's see, what will good look like in the future? So I can't say exactly what that's going to be. The numbers are in there kind of for what good looks like now. It could go down a little bit. It could then go up in future. Like I say, I think it'll come down a lot to what speeds look like for real world users and what people's expectation is. One of the issues, and I don't know how Google will solve this, but one of the issues is that between different markets, people with different levels of connectivity, speeds could be very different. And if you have a website that's aimed at a specific market where speeds tend to be slower, it might be much more difficult then for those users to actually be getting a fast enough speed to have their pages load in such a way that you'll get a good score, particularly for LCP though. And then last question here that I'm going to go through now, but do feel free to send any more questions across. I can get back to later. How to ensure CLS and LCP is good across those different devices. So yeah, so that, as I mentioned, yeah, a desktop site and a mobile site will load in a different way. So those LCP elements will be different. And also, as mentioned, the speed is important. So the easiest way to do that really is just to use DevTools. Within DevTools, you can simulate a different device. And you can also use the performance section in DevTools to identify on a particular load which is the largest Contentful paint element. You can also, within the network part of DevTools, record screenshots, so you can go back through the load on different devices and look at the points when cumulative layout shift is happening and review that. And DevTools also has a useful tool for turning on throttling. So basically you can simulate not just a mobile device, but a mobile device on a slow 3G connection and see what happens. One important thing to remember is that with cumulative layout shift, sometimes on a fast connection, you won't get cumulative layout shift, but you will do on a slow connection. And that tends to be because while your mobile is actually rendering the page, rendering the DOM so it can start showing things, if you're on a really fast connection, then all of your web fonts, all your images and so on are downloading in the background and are ready to show straight away. Whereas if you're on a slow connection, maybe you've actually got the page rendered, the browser starts showing it, but it doesn't have those web fonts ready, it doesn't have the images ready, and when they do download, it has to start shifting things around to fit everything in. So worth looking at that as well and testing those different speeds. Right. As mentioned, there's going to be a download of these slides, including all that information in the appendix. So do get in contact with us here. And we'll be very happy to send you a download link. And as I've mentioned, I'm always very happy to talk about Core Web Vitals. I think hopefully has come across today. So if you've got any more questions, particularly nice, detailed technical questions, then I'd be very happy to discuss those. Thank you very much for watching. I have been Dave Cousin, and goodbye.